So the next thing we have up is our buddy Paul, who's a developer advocate at Stripe, who's going to join us and talk to us about something that I think is equally interesting: card testing. I had not heard of this before. So card testing, a developer's guide to fighting against the dark web. Ooh, spooky. Let's bring Paul on here real quick. I'm going to remove my screen and say hello. Hey, Paul, how's it going?
Hi, good. Thank you for the spooky noises.
Yeah, that's very professional, spooky sounds, right? Thank you so much for joining us, Paul. And
Thank you for
yeah,
having me.
I'm really, really interested in this because I think it's kind of a unique situation that I had not thought of because I'm not, for lots of stuff that I've worked on in the past, I'm not dealing with credit card information that much, but you all at Stripe definitely are, or at least I would hope so, right? So in
Yes,
that
a lot.
case, there's a lot of things from a security perspective that folks need to be aware of. And I imagine you're going to
Yeah,
know
there's
more
a there's
about
a
that.
whole world of scrupulous activity that you need to be aware of when you deal with credit cards. So hopefully my talk will illuminate a little bit more how we defend against that stuff. But it's definitely a topic that a lot of people don't really think about, and I'm really hoping with this talk that it'll get people to think about this a little bit more.
Yeah, for sure. Well, I'll get out of the way and let you take it away from here. All right. I'm going to share your screen. You ready for that?
I'm ready.
Bam. Okay. Card testing. Good. And I'm out of here. Good luck.
Cool. Thanks very much. So, hello, everyone. Like I said, my name is Paul Asjes, and I'm going to talk to you today about card testing, which is a wonderful little fraud activity that, from the depths of the dark web. First, a little bit about myself. Like I said, my name is Paul. I'm a developer advocate at Stripe, and I'm from the Netherlands, and I currently live in Amsterdam. I don't have a hugely security-related background. I was just a full-stack engineer for a long time before I switched to developer advocacy. But I was on the Stripe card testing internal team, so this happens to be something that I know quite a lot about. And just a quick explanation about what Stripe is, if you're not familiar. Stripe is a payments infrastructure company. We have many different products and we do many different things, but what we're most known for is making sure that you can get paid as a developer. We do payments processing, which we're the most famous for. So, quick agenda what I'm talking about today. I'll split it up into three parts. First, I'm going to talk about define what card testing is and what it looks like. I'll talk about what the actual danger is of card testing, what to look out for, and most importantly, how do we actually combat card testing. So, jumping right into it. My favorite definition is card testing is the process of determining if stolen card information can be used to make purchases. This is essentially grabbing a stolen card, which you don't know if it works or not, and seeing if you can actually steal the money that is connected to its bank account. So the easiest way to describe this is actually just to show you how the fraud works or explain how it really works. So step one is that you obtain a dump of cards. When I say dump, I usually mean a stash of somewhere, usually between hundreds to thousands of credit card numbers, often including expiry date and CVC. Expiry date CVC is that little 3-digit code you see at the back of a card usually. I say often, not every single cash will have the expiry date and CVC. The reason for that is that if you look at my example credit card at the bottom right here, the 424242, the 16-digit number, that's the actual card number. And it's actually surprisingly easy to generate one of these. It uses an algorithm called the LUN algorithm, and it's public knowledge. Anyone can use it. So guessing that 16-digit number for a valid working credit card is actually not too difficult. What is difficult is guessing a correct card number, including a correct expiry date and a CVC code. Which makes it exponentially harder to actually guess the right combination. Hence why often these dumps have expiry date and CVC as well. As to where they come from, can be a variety of sources. Could be just people who steal credit cards, to like ATM skimming or hacking some other large establishment. But the next step is verifying that cards are actually still active and can be used. This is the actual card testing part of the whole fraud. This is where you take your massive dump of cards and you want to make sure that you only have the working cards that you use for your nefarious purposes. Now, when you have this huge dump of cards from the dark web, approximately 95% of these cards probably won't work. It's either because they are fake cards that the previous person made up because it's fraudsters all the way down and fraudsters going to fraud, or they have previously been stolen, have been reported as stolen, or have been previously been used, or have been used and we refer to as burned, as in they can no longer be used further. So when you get a cache, approximately 95% of the cards are usually not active. So when you're testing, you're basically reducing this huge dump of cards down to the 5% of cards that actually work. Then I've lumped the next three together. But what happens next is kind of out of scope for this talk, but this is most cases what card testing groups do is they sell these verified cards on to the next person in line, who then do what's actually the hard part of this, which is how do you get these working card numbers? How does that translate into money into your bank account? Stolen money, essentially. And that's difficult to do, a lot harder than this, and also kind of outside of the scope, so we'll skip that. So to explain in a more visual way what card testing is, let's look at an average payment flow you might see. A lot of you, if you use Stripe, this might be familiar to you. If not, I'll quickly run down what this means. We start on the left-hand side here with a customer. Customer clicks a button on your site that says pay. Your client makes a request to your server. Your server then makes a request to Stripe servers, creating what's called a payment intent, which is our payment object. Stripe returns the payment object. Your server returns the payment intent secret to the client. Customer enters their card details, finalizes the order, and then Stripe attempts the payment and returns the outcome directly to the customer, whether it failed or succeeded. So this is a normal card payment scenario that we would see. And this is what it looks like for a card tester. So here on the left in red, we have the card tester. Rather than going for your client, they're actually bypassing it entirely and hitting your exposed endpoint on your server. And this is usually an endpoint which is like creating your payment intent without any sort of security attached to it. So they hit your endpoints, that triggers the creation of the payment intent that we saw earlier. And the payment intent secret then gets returned directly to the card tester rather than to like a client somewhere. And then they use this to make a direct API call to Stripe. And then depending on the outcome, whether it succeeded or failed, they know whether this card actually works or not. So a couple of things to note about this is that, like I said before, the client is completely bypassed. So any security you might have on your client is pretty much useless here. It's not going to do anything. Another thing to note is that this particular type of fraud has a very low risk of consequences. Now, what I mean by that is any like real risk of criminal consequences is pretty much non-existent because most card testers, at the very least, protect themselves behind a proxy. So even if you do happen to have like an IP address of them, it's really difficult to find out who they are, where they're coming from, and how to alert the authorities. But precisely because this has a low risk of consequences and it's so easy to do, because you can find tools and guides on how to card test on the dark web pretty easily. It's actually, this fraud has very small margins. It's pretty cheap to buy a bulk of cards, and it's not too expensive to actually card test as well. But it means that when you sell on these verified cards, you're not charging much more than what you initially paid for them. So really tiny margins. So often the card testing is actually in the middle part of a fraud ring. The first part is actually, obtaining the stolen cards. Middle part is testing, and the final part is then using those verified cards and turning that into money into your bank account. So that's a really brief run over of what card testing is. Next thing, I'm going to talk about what the actual danger is. Like, why should you care as a business about card testing? Well, it turns out there's actually a lot of reasons, really good reasons for you to care. We'll start with fines, declines, and disputes. If you're not aware, a dispute is when you see a charge you don't recognize on your credit card statement. You call up your bank and say, hey, I don't know what this is. I don't think I did this. I'm disputing this. What the bank will then do is they will investigate this dispute or this charge. And in the case of card testing, they will almost always rule in favor of the card holder, which means that the funds automatically get refunded to the card holder, and you pay the cost for that. When you are being card tested against, you'll probably have a lot of declines, but you'll also have several successful card testing charges. And successful charges means disputes. And every dispute that you get comes with it a pretty hefty fine, potentially. Secondly, declines beget more declines. What this means is that Stripe works on top of the traditional card network. So Visa, American Express, and MasterCard, who have their own risk machine learning algorithms to try to detect fraudulent stuff like this. If you start getting lots of declines on your merchant account, then that will automatically trigger these card networks to start looking at all the transactions in your account from a more riskier point of view. So for instance, if you have a legitimate customer who's trying to buy something from your website, but the thing that they're buying is outside their usual spending habits, normally the card networks might say, well, this is a bit unusual, but we're going to let it through because it's not that bad. However, if you have lots of declines in your account, this might kick them into a bit of a higher tier of risk assessment, and they might decide to decline that otherwise perfectly acceptable normal charge. So you could actually lose revenue pretty quickly with this. And then finally, a huge danger of card testing is that if you don't do enough to fix the problem, if you are being card tested, you can actually be fined by the card networks, who might charge you inordinate amounts of sums because they feel that you are not being a good citizen and not fixing the underlying problem. Because API requests, they're actually not free. They cost money for these card networks as well, and it's in everyone's best interest to not have any card testing. And finally, there's infrastructure strain, which is a huge problem as well. So certain card testers will try to fly under the radar and just test in like small little bursts where they hit your API. This is more common for merchants that have a lot of API traffic for Stripe, where they just try to not get noticed. Whereas others try to just brute force their way in. They have a cache of potentially hundreds or thousands of cards. They want to get them as fast as possible, so they're going to hit your API really hard. And they might DDoS you, and your whole site might go down because of this. Another real danger here for infrastructure is the unexpected cost if you're using auto-scaling. Say like you have a load balancer on your backend, and you suddenly get 10x the amount of traffic that you would normally expect at this time of day because of card testing. Your load balancer might decide to let's spin up some more instances because clearly, business is good. And you might find at the end of the month a really high infrastructure bill for your cloud service provider of choice. And then finally, and this is more of an admin thing, but it's just as painful, is cleaning up the mess, the aftermath of everything. So for charges that go through that are fraudulent, if they haven't been disputed, it's in your best interest to refund them as fast as possible so they don't turn into disputes. This could, if you have hundreds of fraudulent charges, doing this by hand by the Stripe dashboard is super painful. So you probably want to automate this, but even then, it's extra resources and engineering time that you really don't want to spend time on. Same goes for mass deleting fake customers. Usually this comes with a lot of fake users that aren't real. You don't want them hanging around. And the final one, most important, is recovering legitimate customers. So if a legitimate customer gets hit during card testing, as in they are unable to make a purchase from your website, getting them back to make the purchase of whatever the thing they were trying to buy is surprisingly difficult. A lot of people, if they have any sort of problems with your site, they just move on and they try to find a different vendor to do the same thing. So that's why you should care about it. Now we come to the most important part, which is how to combat this. So I'm going to outline 3 main mitigations against card testing here that I hope you'll implement at least 1 or 2 of them. The first, and probably the most effective, is quite simply a Captcha. So we all know these. We've all seen them before. We've all had to pick bikes from several pictures. Here I've got at the top here, we've got reCAPTCHA, which is Google's offering. At the bottom, we've got HCAPTCHA. Either are fantastic choices. You can't really go wrong. But to really explain this, let's go back to the previous flow that I showed, the card testing flow. So the important thing that I mentioned here was that the client is completely bypassed. So you might think, well, what's the point of having a CAPTCHA if there's no client to put the CAPTCHA on? Well, that's because we don't want to necessarily do verification of a CAPTCHA on the client. What we want is server-side verification. We need this CAPTCHA to be on our server. How this works is that with most CAPTCHA clients, you implement it on your client, and you get what's a token. So here's an example of a post we've been making from our clients to our own backend. Here I'm using Quick Fetch API to hit this create payment intent endpoints, and I'm posting. But more important, in the body, I'm putting this token that I'm getting from, in this case, Google's reCAPTCHA. Then on your server, immediately, if you have a request to your endpoint that does not have a token, immediately return a 403 because it's not authorized. If there is a token, you would then make it an additional API call to Google. In this case, we have got the CAPTCHA secret. That's basically your secret API key, and you've got the token, which you get from the client. You send this over to Google, you get back an object, and in there we have this CAPTCHA.success, which is a Boolean. And if that's false, which means that the CAPTCHA was not solved, then immediately you send back a 403 because there was no human behind this, probably. So I'm going to show a quick demo about how this works, and hopefully the demo guys are with me. So here is a page showing off Stripe's payment element, which is this thing you see in the middle here. And what I'm going to do is I'm going to select card, and I'm going to fill out some card details, which is, this is the test number with a random expiry date. I'm going to put in my CVC, and I'm going to click pay with payment element. And we're going to wait for a sec. The page will probably reload. And there we go. It says previous payment intent status conceded. And you're probably thinking, well, hold up, where's the CAPTCHA? Now, some of you might have noticed on the bottom right-hand side here, I've got this little protected by Captcha badge. What I'm actually demoing here is not the Captcha you've probably seen before, which is the version 2, which is the different images. This is an invisible Captcha. Now, what Google is doing behind the scenes here is looking at things like mouse movement and user agent and other behaviors to determine whether you are a bot or not. So from a consumer point of view, this is actually pretty frictionless. I think you wouldn't even notice that you're being vetted. You're basically having a Turing test done against you. To give you an idea, here's a look at some of the code. We have here on my front end, I have this reCAPTCHA ready and executes with my secret key. Well, it's either a public key here. You see that I'm posting to my endpoint with this token. And then on my server, which is here, I'm doing the same thing that I said before, where if I don't have a token, I'm returning a 4 or 3. I'm being kind here because I'm actually sending back an error saying there's a missing token. In production, I probably wouldn't do this because you don't want to give any hints about what's missing here. The only thing that you want to be hitting your endpoint is your client, and you know what you have to send. So you probably wouldn't send anything except just a status here. But again, I'm making a fetch request to Google with the Captcha secret and my token. And then in the result, it's a success. Then I go ahead and actually create my payment intent, and I return that to the client. So some pros and cons here. The pro is that this is really a non-trivial hurdle for card testers. This is a huge roadblock for them, because rather than being able to hit an unsecured endpoint, they suddenly have to also figure out a way to generate a reCAPTCHA or HCAPTCHA token, which is obviously very difficult to do. It's also nice about this is it's quite a low engineering lift. It's just it's a client-side library, and it's just an additional fetch on your backend, which can be seen as a downside because it is an additional API call. And if you're doing lots of these, then it might hurt latency a little bit, but it's not that huge of a downside. There are debates going on about whether CAPTCHAs hurt your conversion rate. Now, if you're not familiar, conversion rate is basically the percentage of users that show up on your website that you convert into paying customers. Some people say that having a CAPTCHA on your site, decreases your conversion rate. Other people say that it's actually fine. Your mileage may vary, but it's something to consider. And a little pro tip here is to use feature flags to enable CAPTCHA. When I say feature flag, I mean have a switch somewhere in your backend that you can just flip on and off to enable the CAPTCHA. So if you are under card testing attack and you detect this traffic, flip the CAPTCHA on. Card testing should probably subside by itself, and then when that goes away, you can turn it back off again if you feel the need. So the next mitigation I'll talk about is rate limiting, another very highly effective. So if you're not familiar, rate limiting is basically just funneling requests to your API and dropping requests if too much is hitting your API at the same time. This is mostly common towards protecting yourself against DDoS attacks, but it's also really effective against card testing. Which is reflected here in the pros and cons. So yeah, protects you against DDoS, but more importantly for card testing, it actually makes card testing against your integration wildly inefficient. So if you imagine a normal paying customer, you think like, how often do they really need to make a payment on your site? Do they need to be able to call this endpoint? Probably not more than like once every few seconds, realistically. However, a card tester wants to hit this endpoint multiple times per second, probably. So if you implement rate limiting on this one route that says this can be hit, for instance, per IP 1 time per second, then a card tester who's trying to get through a cache of hundreds to thousands of cards, this becomes wildly inefficient. Rather than be able to do like 10 per second, only 1 per second, suddenly the time to completion for them is 10 times as much, and the chance of them being detected and stopped is also much more of a risk for them. So like I said, this is very effective when you pair this with IPs. If you happen to be able to catch card testing, you know what IP is from, you can just block the IP itself as well, or you can throttle it like I just talked about. The downside is that this can hurt legitimate customers as well. If you are not doing IP throttling with your rate limiting, if you say that only 10 people can hit this particular, or 10 requests can come to this endpoint at a time, and a paying customer is the request number 11, then they're kind of out of luck. They get a 429 error, and they have to either try again or they might just bleed forever. And this is less effective if the testing is more advanced. So if they're using a single IP address, you can just block that IP address and move on with your life. If they're cycling IPs, you're basically playing a game of whack-a-mole, and it sucks. It's terrible. And my pro tip here is that use rate limiting for your vulnerable routes rather than your whole application. Like, you probably don't need rate limiting just for your front end, for your index page, but you do need it for endpoints where you're making business transactions. And then finally, the last mitigation I want to talk about is barriers. Now, this is possibly a vague and very wide category, but barriers is basically anything you can put between card testers and your endpoints that makes life difficult for them. So the canonical example of this is requiring a login or like a session validation, but you could also be like filtering via user agent, or you could be limiting that the amount of payments can be made with like from a single IP address, et cetera, et cetera. The pros here is that any hurdle that you have makes you less attractive as a target. Card testers really are looking for the juicy, no security, easy targets that they can hit with this, because this is purely for them, just a business transaction. They're not after you specifically. They are just using you to get to Stripe and the card networks. And they're essentially hijacking your Stripe API key to do that. So any hurdle you put between them and your endpoints is going to be a reason for them to leave you alone. And this really hurts them where this hits the hardest. Where it really hurts them is their bottom line, because card testing, like I mentioned earlier, has very low margins. So if you are able to add more barriers, which makes it more expensive for them to get to break through that, makes them spend more engineering time or more processing time to do stuff, then you're hurting their bottom line, and they're far more likely to move on and not card test against you. And the cons here, rather obviously, adding barriers can introduce legitimate user pain. If you are filtering on user agents, let's say that card testers are, for some reason, sending you a user agent that looks like a Nintendo 3DS browser, and you happen to have one legitimate user who is using a 3DS browser, they could get caught up in your caught up in your rejections as well, which is not great. My pro tip here is to look for obviously fake or reuse data in requests. So card testers are not the most inventive bunch of people. They tend to use the same dummy data over and over again, like the same name, email address, and business address. Sometimes they will use very predictable patterns, like randomly generated first name dot last name random string at gmail.com or whatever. Look out for that obviously fake data so you can actually implement some barriers yourself. So now you might be thinking, like, okay, which one of these should I use? And the answer is you should probably try to use at least two of these. At least if you can have these in a place where you can flip the switch on and off, that's already a pretty good place to start to protect yourself against this kind of attack. And the next thing you might think of, okay, that's great and all, but what does Stripe actually do? And Stripe, I'm using Stripe generally because it happens to be my employer, but other payment processors are very similar, also probably doing similar things to what we are. Well, the answer is we use all of the above. We have Captcha in place for our checkout product. We use sophisticated machine learning to detect card testing so that we can accurately rate limit. And we introduce barriers like collecting business addresses and email addresses in our checkout product as well to add any kind of barrier. Now, this is a security conference, so I'm pretty sure there's already a bunch of you in the audience who are thinking to themselves, well, that's great, but I can already think of at least 5 ways to get past your immense security here. And you know what? You're absolutely right. And also, that's actually okay. Because the funny thing is that we're not really trying to stop card testing forever. What we're really trying to do is stop card testing against you. Because card testers are lazy and working with small margins. So any barrier is a compelling reason to stop testing against your system and try somewhere else. This kind of reminds me of the joke of the law of the jungle, that if you and a friend are being chased by a lion, you don't need to outrun the lion, you just need to outrun your friend. In the case here, like, you're not trying to stop card testing forever. You're just trying to stop them from hitting you, where it could be expensive and potentially a company-ending event. So saying that, how do we actually really, for realsies, stop it forevermore? And the answer is kind of depressing in that in order to stop this forever, we need a legislation and a policy change and kind of like a systematic change of how we approach credit cards on the internet. Just having a card number, an expiry date, and a CVC, you're all security experts, you probably know, is not a very good way of protecting oneself from fraud of this nature on the internet. So the good news is that some help is on the way. In the European Union in 2019, they put into effect the Strong Customer Authentication, or SCA law. What this basically means is that any credit card transaction that happens in the EU or within the EU's digital borders requires something called 3DS, which, long story short, is basically two-form authentication for your credit card, where you have to have either a password, PIN, like a banking app that you can log into, or like a fingerprint to authenticate any sort of online payment. And the result is actually that we've seen far less card testing attacks against European cardholders than we have in the rest of the world, just because of this extra authentication step added. Adding this makes it far too expensive for card testers to be able to do anything meaningful here, and actually verifying cards becomes impossible when you have when SCA is in effect. Now, the bad news, unfortunately, is that, to my knowledge, at least, and at the time that I'm giving this presentation, there are no plans for enacting similar legislation in the US or even the rest of the world. It's something that's the finance industry is a very slow-moving one. So hopefully in the next couple of years, we'll see more advances in this fight. But for right now, really the trick is to stop card testing against your own business rather than trying to stop it like worldwide. So in conclusion, hopefully you learned today about what card testing is, you've learned about what the danger is, and you've learned how to combat it. I really hope that you have learned something from this today, and I hope that this has been a bit of an eye-opener that you do have to look out for these types of things, because there are lots of fraudsters out there. And it's like with most things in security, unless you might not know about it, but once you get burned by it, you will never forget those lessons the rest of your life. So thank you very much, and I welcome any questions.
That's awesome, Paul. That was really, like, insightful, and I'm not just saying that because, as I mentioned at the top of the session, like, this whole card testing thing is completely new to me. So, uh, what I will say though is Captchas are, like, they're just terrible.
I know. Like I
understand.
don't make the recommendation because I like Captchas. I make the recommendation because they're just effective and they work.
Yeah,
But they
no,
suck.
I totally get it. They just can be, sometimes they work great, and then sometimes it's like I go through and I'm like, "I'm not a robot." Like,
I know, and
why do
especially
you
the
think
ones
I'm a
that are
robot?
they're set too strict where you start to question yourself, am I a robot? I can't, I don't know.
Yeah. Yeah. So I see a great question in the chat from Potato Scream, by the way. Do you all happen to have a GitHub repo with some, like, baseline examples with the CAPTCHA and barriers that you suggested that we can maybe
They don't
share?
have a GitHub repo, but the code, the demo that I gave earlier is actually up on Glitch, which means that you can see the source code behind it if you want to check that out. So I can definitely put the link to that. And yeah, we can absolutely look at, we have something called Stripe samples where we often publish how to do stuff with Stripe. So we can definitely look into building one specifically for anti-card testing.
Gotcha. All right. I'm going to ask, actually, Hacker Kyle in the chat has a question. Have you been noticed any interesting slash noteworthy trends in data related to carding through your experience?
Yeah, so the interesting thing that we've found is that people who are under attack from card testing, the soon as you kind of let on that you're on to the card testers, to the fraudsters, a lot of them just tend to give up
Mm.
straight up. Like they just move on to the next victim because it's not worth their time to try and bypass your defenses. They much rather just find another juicy target somewhere else. So it can it's like I said before, it's very much once you get hit by it, once you get burned by card testing, it's not kind of a lesson you'll never forget.
Mm.
But a lot of people have to get burned by it before they decide to really take it seriously. And just the smallest barrier can really stop people in their tracks and say, this is too much effort. Because I mean, a lot of these card testers are quite literally script kiddies who have found a tool or a guide on the dark web. They're not security professionals. They don't know how to get past your barriers. And these guides are, I've seen a couple of them. They're not great. A lot of them are very outdated. And yeah, they just, yeah.
Oh, well, fair enough. Thank you, everybody in the chat, for your questions. And thank you again, Paul, so much. Super informative. And I hope to talk to you again soon and learn more from
My
you all.
pleasure. Thanks for having me.
Thank you so much. I'm going to pop you off here. Have a good rest of your day, bud.